Good day, students. In this video, we were gonna talk about the trigonometric identity. This includes reciprocal and quotient and Pythagorean identities. When we say trigonometric identity, means that it's identify that involve trigonometric functions of one or more variables. First is a reciprocal identity. In trigonometry, a reciprocal identity is the reciprocal of one of the basic trigonometric functions. The reciprocal identities are the trig function, secant, cosecant, and cotangent. And this is the equation of reciprocal identity. 1 over sine theta is equals to cosecant theta. 1 over cosecant is equals to sine theta. Next, sine theta cosecant is equals to 1. 1 over cosine theta is equals to secant theta. 1 over secant theta is equals to cosine theta. Next, cosine theta secant theta is equals to 1. 1 over tangent theta is equals to cotangent theta. 1 over cotangent theta is equals to tangent theta. Next, tangent theta, cotangent theta is equals to 1.
So this is the second identity, which is the quotient identity. In quotient identity is an identity relating the tangent of an angle that sin of the angle divided by cosine of the angle.
And this is the equation of quotient identity. Tangent theta equals sine theta over cosine theta. Next, cotangent theta equals cosine theta over sine theta.
Okay, so the Pythagorean trigonometric identity is also called simply the Pythagorean identity. So it is an identity expressing the Pythagorean theorem in terms of trigonometric functions. Along with the sum of angles formula, it is one of the basic relation between the sine and the cosine function. The identity is as usual means. So here is the Pythagorean identity. So x squared plus y squared is equals to 1. Cosine squared theta plus sine theta is equals to 1 divided by sine squared theta. And sine squared theta equals to sine squared theta. So cosine squared theta divided by sine squared theta plus 1 is equal to 1 over sine squared theta.
So this is the first example. Example A. So this is the first given. Sin theta, cotangent theta, secant theta is equal to 1. So we need to know that this side is equal to other side or the right side. Use the fundamental identities from our left side. We should use those identities to prove or solve this problem. So step 1. Sin theta.
Okay.
So in the trigonometric identities, the cotangent and quotient identities is equal to cosine theta over sin theta. So this is our quotient, and times to in the reciprocal identities, the secant theta is equal to 1 over cosine theta. And copy the 1. Step 2, multiplying fraction. So after the multiplying fraction, the result is sin theta, cosine theta over sin theta, cosine theta. And simplifying fraction. Sin theta, cosine theta over divide sin theta, cosine theta is equal to 1. In this case, the operation is a product, and the other hand equation is addition. So in the given, we simplify the operation add. Step 1, copy the first equation. We should use the reciprocal identity because of the squared of the equation. So the reciprocal identity of secant squared theta is 1 over cos sine theta plus 1 sine squared theta. Then copy the first equation. Add this fraction sine theta plus cos over and this is the result of after we add the two fraction. So copy again the first equation. Equal. So as you can see in the numerator of this fraction is we have a add operation or the addition. So in Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. Then copy the denominator of the fraction. Then copy again. And after this, we have two fraction, 1 over cos squared theta, 1 over sine squared theta. So we have to get the reciprocal of this equation. So copy and get the reciprocal of this equation. So 1 over cosine squared theta is equal to sec squared theta, and times the 1 over sine squared theta is equal to cosecant squared theta, and this is the result of this equation. Therefore, we prove that the given is equal. So this is the last equation, the trigonometric equation. The cosine squared theta minus sine squared theta equal cos raised to the power of 4th theta minus sine raised to the power of 4th theta. So in this equation, we can use the grade 8 topic, which is the factoring. We should process the right side. The cos so Like the exponent is 4, so that's why we have to make a binomial. Cos squared theta. The operation is addition. And the other equation is subtraction, operation, inside squared theta. As you can see on the right side of the equation, which we have addition sign and we have the subtraction sign. Copy the cosine squared theta, sine squared theta. And as you can see in the Pythagorean identity, if the equation is cosine squared theta and the operation is addition, it is equal to 1. So that's why we have 1. And copy the subtraction sign. And after that, we need to multiply the 1 on squared cosine theta, squared sine theta. And still the answer is cosine squared theta sine squared theta. 1 times cosine squared theta minus sine squared theta is equal to cosine theta. That's all.
Take.
And as you can see, it is the same equation in the left side and the right side.